Alright guys, welcome to this page of the notes, and what we're going to do now is take a look still at graphing radical functions or functions with radicals in them, but now they're going to be inequalities. And we have done inequalities before, so you guys already know when graphing inequality, you're going to be shading a certain portion of the graph. The shaded part of the graph is just going to represent your solution region, meaning anything that's shaded represents a solution for the inequality. And since we've done these before, you guys should remember the process that we go through, but we'll review it here just in case you've forgotten or are just now joining us for this Algebra 2 course. It's a simple 4-step process to graph and shade an inequality. We'll go ahead and take a look at that process as we run through this first example problem. Again, let me highlight this for you though, since we are doing inequalities. You will follow the same rules and steps as we used for solving any other inequality. I'll review those rules with you as we go through this. So here we go. Let's jump right into this one. You're given the function y is less than the square root of 2x minus 6. Hopefully what you guys remember is that step 1 is to ignore the inequality. We ignore the inequality and we graph the related function. So y equals the square root of 2x minus 6. For now, I'm going to just ignore the inequality. We don't care. I need to get my graph on there. I need to at least get my graph on there. So we're going to graph this function. Well, we already know how to do that thanks to previous example problems. I need to set up an XY table and choose some smart values, right? I want things that give me a perfect square. We're going to start off with 0. I need to figure out how to get a 0 under here. And it looks like if I plug in a 3, 3 times 2 is 6. 6 minus 6 is 0. The square root of 0 is 0. So my first point is going to be 3, 0. My next perfect square is 1. So I need to figure out how to get a 1 under here. And again, the only way to get a 1 under here would be to get a 7. But there's no way to multiply a non-decimal by 2 and get 7. So I'm going to skip the perfect square of 1 and let's go to the perfect square of 4. How do I get a 4 under here? Well, I think if I had a 10, right? 10 minus 6 would be 4. And how do I get this to be a 10? Well, x would have to be a 5. So if I plug in a 5, 5 times 2 is 10. 10 minus 6 is 4. And the square root of 4 is 2. My next perfect square is 9, right? So I need to figure out how to get a 9 under here. Well, to do that, I'd have to have, let's see, 15, right? 15 minus 6 is a 9. But there's no non-decimal I can multiply by 2 and get 15. So that's not going to work. What about 16? If I can get a 16 under here, which actually I think is going, I think that one's going to work. How do I get a 16? I would have to have, I need to get a, no, wow. I guess I'd have to be at 22. Can I get to 22? 11. That's it. So if I plug in an 11, 11 times 2 is 22. 22 minus 6 is 16. The square root of 16 is 4. I know that that one is not quite on my coordinate plane, but it's close enough I can fudge it. Let's go ahead and graph these guys. 3, 0. 5, 2. And 11, 4. Right about there. Just off my coordinate plane a teeny little bit. Now let's go ahead and graph those guys. Oh, actually, sorry. Don't draw your line yet. The next step, step number 2 in graphing inequalities, is to figure out if you need a solid or dotted line. Well, remember the way we do that is now we take a look at the inequality that you were given. If it is strictly less than or strictly greater than, it's going to be a dotted line because the line is not included. It's strictly less than or strictly greater than. If it's less than or equal or greater than or equal, the line is included and you would use a solid line. I have strictly less than, which means we're going to be dotted. And so let's go ahead and put our dotted line in here. All right, so there is the graph of my related radical equation, ignoring the inequality, graph the function, and then I get solid or dotted by considering the inequality. Now I need to work on the shading portion of it. I'm either going to shade what's under the radical or shade what is outside of the radical. And what that means is you actually need to add a little bit extra. You're going to need, from your starting point, to drop a line straight down. Hopefully you can see that green line. Just make it a dotted line, right? It's just to help me with my shading, right? I'm either going to shade the region under the radical equation because that's my solution region, or I'm going to shade the region above the radical because that's my solution region. But I've got a dividing line right here at my starting point, right? Because I can't shade for you guys, what would be to the left of my starting point, because that would be where I would get imaginary numbers and it would be part of my solution region. It's just what's directly under the radical. So I drop that line straight down and shade just what's under here. Should make sense. If I'm shading the outside of it, I drop that line straight down because I don't want my shading to creep in underneath of my radical because that's not part of my solution region above the radical. So here we go. I just dropped that line straight down to help me separate those two regions. I now have the region under or the region above, and let's go ahead and figure out which one needs shaded. That's step 3. Choose a test point. Okay, when choosing a test point, you're going to want to pick a point that is underneath the radical, the graph of the radical. Pick a point that's easy to work with. But you're going to want to pick a graph that's under the radical, right? So, since this is the graph of my radical, I can pick any point I want to underneath of that radical. Anything underneath it here I'm going to pick. And an easy one, since my graph starts at 3, 0, I'm going to go with 4, 0, right? That's easy to do math with. 4 and 0, easy numbers. It falls underneath the graph of my radical, and so that's the point I'm going to pick for this one. You can pick any point you want to. I'm going to go with 4, 0. Step number 4. Use your test point to figure out if it gives you a true or false statement in the original function. So plug test point into original inequality. Okay, so here we go. My original inequality was y is less than the square root of 2x minus 6. So let me slide up here so you can see my work. It was y is less than the square root of 2x minus 6. So now I'm going to plug in my test point. That's my x, that's my y value. So 0 is less than the square root of 2 times 4 minus 6. 0 is less than the square root. 2 times 4 is 8. 8 minus 6 is 2. And the question is 0 less than the square root of 2? Now I know that 2 is not a perfect square. You're going to get an irrational, a non-repeating decimal here. but it's a positive number, and any positive number is bigger than 0. So this is a true statement. And here's what that means. My test point was underneath my graph, right there. And it gave me a true statement, which means it's part of my solution region. So I need to shade everything, right, that includes this test point, which would be everybody underneath the graph of my radical. So I'm going to shade everybody under here. This represents the solution region of my inequality. Everybody underneath of the radical symbol. It's got to be a dotted line because the line is not included. It's just the points underneath of it representing my solution region. Again, 4 simple steps to graph an inequality. We've done these before. The only difference here is now they're radical functions, right? And you got to choose a test point that falls underneath of the graph of your radical, but still pick something pretty easy and then shade from there. Head on over to the next page of the notes. We'll try one more of these together. I'll meet you guys on that page.